Okay, so 2.1, the derivative and the tangent line problem.
No.
Yep. Okay, calculus grew out of four major problems that European mathematicians were working on during the 17th century. The tangent line problem, the velocity and acceleration problem, the minimum and maximum problem, and the area problem. And next to those, we're showing you where we're going to look at them at. We looked at tangent line in 1.1. We're going to look at it in this section. Velocity and acceleration is 2.2 and 2.3. Minimum maximum was 3.1. And area problem is 1.1 and 4.2. But I'm going to tell you that all of those problems are addressed in almost every section, but those are where you're introduced to them in. So calculus is the study of change and continuous change and instantaneous change. And we no longer have a constant rate of change. We have instantaneous rate of change, and therefore we have to figure out the slopes of tangent lines because rate of change is what that is. Okay, so tangent line is a line that intersects at exactly how many points? 1. So these are different kinds of graphs where a tangent line exists. Up here, the slope is what? 0. Okay, it's the maximum. Where else would the slope be 0? At a minimum. Okay. It is decreasing. The slope is decreasing when the graph is decreasing. Increasing when the graph is what? Increasing. Okay, so use a graphing utility to graph the function, and then on the same, we're not going to mess with that. I need to take that out. We've explored that many times in the last 2 years. Okay, so what we have talked about already is the secant line, the average rate of change between 2 points, correct?
Yeah.
We don't want average rate of change because on nonlinear things, average rate of change does not do me a whole lot of good. Okay? Our goal is to bring these 2 points that we start with closer and closer and closer and closer and closer and closer until we get to a not secant line, but
a tangent line.
But a tangent line. So that's what we're going to be working on. So M of the secant line, you have seen this before. You may want to write it down again because you will be expected to know it on this test, your final this semester, and your final next semester. So, the slope of the secant line is equal to f of c plus the change of x minus f of c over the change of x. We have done this already, yes? Yes, we have. We have done the quotient formula thing, and you thought it was the worst thing you'd ever seen. Well, you're just going to see it more. On the right-hand side is what we call the difference quotient, and that's what we introduced it to you as. Just a little fun fact. In 1637, the mathematician Descartes stated this about the tangent line problem. And I dare say that this is not only the most useful and general problem in geometry that I know, but even that I have ever desired to know. So we always want to know when something specific is happening, and when we don't deal with linear objects, which our world is not linear. It just, in math, is linear until you get to Algebra 2. We need a way to manipulate that world. Am I good? Suppose. Okay, so wait a second. Look at this right here. Yes? And look at this.
I didn't look at the other thing.
This one or this one? This one or this one?
That's the same picture.
This one or this one? You feel you're at the eye doctor? First one or the second one? Are they the same thing?
Yeah.
Yes, except for what did we add?
Limit.
The limit as
Delta X.
what is delta change? Okay, so the limit of delta x is limit as delta x approaches 0 of the difference quotient gives you the slope of what line?
The tangent
The tangent line. So it's the secant line until I put the limit, because that limit is bringing your 2 points. That limit becomes the distance between these 2 points. And that is getting closer and closer to what?
The tangent.
To 0 and the tangent.
I don't know what you were asking.
Yeah, that's okay. I don't know if I really was looking for an answer. I just wanted you to be thinking.
You know, I never really know.
So this is what you will be using for the next 2 days.
Oh, will I?
What if we don't?
Oh, we'll probably get a lot of stuff wrong. Okay.
The slope of the tangent line to the graph of f at the point C of f of c is also called the slope of the graph of f at x equals c. The limit is the slope at the constant, okay?
I'm gonna go clip that sound.
Okay, find the slope of the graph 2x minus 3 at 2, 1. Now you all better tell me the slope is what?
I'm gonna say 2.
Is 2. Yes, that is linear. But we are not going to simply be satisfied with Kale's knowledge of linear equations. We are going to use the tangent line formula that I just gave you. So the slope of the tangent line equals the limit of delta x as x approaches 0 of what?
F parentheses C plus F of X, Fx, not F of X, minus F.
Isn't it delta x?
I didn't write it as delta either times.
I'm pretty sure it is.
It's embarrassing, kind of.
Oh, my handwriting looks like I just had major issues here.
Well, I'm done talking for the weekend.
So f of c, right, plus delta x minus f of c over delta x.
Yep.
So this tells me I have to put c plus delta x into my function for x, yes?
Yep.
Okay, so I have the limit of delta x approaches 0 of 2 times c plus delta x minus 2x plus 3. Where'd I get minus 2x plus 3?
No idea. Oh, they're just kidding.
The formula says negative f of c, right? Oh, that should not be an x. It should be a what?
Delta.
C. It should be a C. But how did my 2 become negative and my 3 become positive?
Because you just remove the negative.
Yep.
throughout.
Exactly right. So now what?
Now you simplify.
Now I simplify. So I have 2c plus 2 delta x minus 2c plus 3 over delta x. Follow on?
Yep.
What? What's wrong?
Nothing.
You said problem, you said yep.
Oh, I thought you said following along.
I'm feeling we have a problem.
Well, Houston, I don't know.
I'm feeling we have a problem. Oh,
We have a problem.
no. We don't have a problem yet. 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 What did I do wrong?
can't tell you because you're supposed to be teaching us.
No, I wrote down the problem wrong.
Yeah, well, the first two C plus delta x, did you forget that minus 3 before going into f of c?
Yes, I did forget I forgot the -3 right here. See that?
Why did you do
Because, let me not skip steps. But when I wrote down the problem on the slideshow, I wrote it wrong too. Okay, so when I plugged this in for x, right here, yes?
that?
What did I forget to write down?
The negative 3.
The -3. Now I'm going to distribute the negative through the problem. Sorry, guys. 2x plus 3. So I have 2c plus delta x minus 3 minus 2c, and that should be a c again. I did that again. When tomorrow I will not be using c's anymore, I'll be using x's because that's what you just tend to do is use x's. Did we use x's when we did the difference quotient?
I think
Yeah.
so.
We just kind of quit using the c's and use the x's because it's the same thing. Okay, so 0, 0, 0, 0, and I forgot my 2. See, I'm really doing good.
You're like really killing it.
I know. I'm doing amazing today. Maybe the second one will go better. So now I'm down to the limit of delta x approaches 0 of 2 delta x over delta x, which is just what? 2. What was the slope?
2.
2.
Wow, look at that, guys.
So that is the proof of the slope. Now, I am not messing up the next one, I promise.
Give me a second to catch up.
Okay.
And to rewrite everything.
In your problems, they will tell you from time to time, they'll say, on this one, they did and I didn't write it, they said C equaled 2. Okay? Well, the constant equals 2, that's fine, because what? It's right here. You can put this in up here, or you could put it in your answer if you still had a C.
But we don't.
Not in this one. Okay. Now let me not mess this one up. It's the same problem. Okay. Find the slope of the graph of x squared plus 1 at points, at points 0, 1 and -1, 2. So we are first going to find the slope function, and then we are going to plug in our x's. Because that's the whole point of this. We are finding the slope function of the function. So we can find any slope at any point we want. So the formula we have again is the limit, and I will keep writing it, and I encourage you to keep writing it until you know it frontwards and backwards. Okay? Of what? F of
Oh, f of c plus the change of x minus f of c over the change of x.
So I have the limit, change delta x. So now we have c plus delta x squared plus 1 minus x squared minus 1, not x. See? Over delta x. So now I need to expand, correct?
You sure do.
And what do I get when I expand?
C squared plus delta x squared plus 1 minus x squared minus 1. C squared minus 1. All over delta x.
I would encourage you to put your delta x when you square it or cube it or whatever in parentheses. because we need to remember it's the whole delta x squared, not just the x. Those things, that is one thing. I cannot reduce out the x and whatever. Okay, so my c is reduced, yes? My 1's reduced. So I now have the limit of delta x as delta x approaches 0 of 2c delta x plus delta x squared over delta x. Can I reduce that some more?
Yeah, factor out a delta x.
I can factor out a delta x, can't I? So a delta x can come out of everything. So that leaves me with the limit of delta x approaches 0 of 2c plus delta x, which just gives me what? Well, delta x is approaching 0. So how do I find a limit?
0.
I plug in 0
You plug in
for delta x. So 2c plus 0 is
2c.
2c. So we just found what?
The slope of the graph at point 0, 1.
Slope equation of the tangent line. Now, we just found the slope equation of the tangent line. Did we find the slope of the tangent line?
No.
No. So we're going to say what, Natalie?
How is that equal to C?
Because as x, change of x approaches 0, so I plug in 0 here,
Oh, yes.
I get 2c. So m at 0, 1 equals, our constant is our x value. So if I plug in 0 to our equation, I get what?
0.
0. I get 2 times 0, which is 0.
Oh, 0.
Okay? Now the slope of the tangent line at negative 1, 2 is 2 times negative 1, which is
Well, that's the stumper.
negative 2. So again, this is the slope of the what?
The tangent.
Tangent line. This question will be on almost every single one of your tests from here till the end of the semester, year. It will be find the equation of the tangent line. Well, what's that? Right there. And then it will say find the slope at this point, which is right there. So that's 8 points on almost every test from here until the end of time.
So the C is just
The C
equation.
is just the x. If you guys are okay with it, we can change that C to an x now.
Sure.
Just remember, if they give you a constant, you can plug it in for that x or c.
Oh.
We change it there anyway. Do we need, I don't think I have another one. So do I have any questions? Have we done the difference quotient already?
Show.
Yes. All you're doing with it now is what do I get? What is this again?
2C.
I know, but what is it?
Slope equation.
Equation of the slope of the tangent line.
Yes, it's the equation for the slope of the tangent line. Okay, so that's what your goal is to do today. And all your problems, you are doing this on every single problem. So your equations are just going to get more complex.